In this video, we're going to talk about the basics of confidence intervals. Last chapter, we talked about samples from a larger population, and we talked about all the different ways you can analyze those samples in order to make your estimated guess as to what that parameter would be for the entire population. So that chosen statistic of a sample is something that we call a point estimator. So that is the thing in the sample that provides an estimate of our population parameter, the thing that we're looking for. And so whatever value that point estimator takes is called a point estimate. So oftentimes our point estimators are given in terms of a range or on an interval. So we might say, well, the average heights of all students in our class is somewhere between 5'5" and 6 foot. So that is an interval. Somewhere on that is the actual true average of all student heights. So in statistics, we call that a confidence interval. And so that gives an interval of plausible values for a parameter based on sample data. And usually the most common confidence interval is a 95% confidence interval. Sometimes you'll even see up to 99%. Obviously, it's going to be based on how accurate you can be and want to be. And within that, we have something called margin of error, which I'm sure you've heard that phrase before. But in our context, the margin of error of an estimate describes how far, at most, we expect the estimate to vary from the true population value. And so normally, we say something like, we are C% confident that the interval from whatever to whatever else captures the whatever you're looking for. So visually, it looks something like this, where our point estimate is like, all right, the average heights of students in our class is about 5'8", maybe 5'9". And of course, we want a reasonable margin of error. And we want to be confident with at least 95% accuracy, or at least the interval that we give, we are 95% accurate that our true parameter value lies in that interval. So let's actually take a look at an example about interpreting a confidence interval. This one's called Who Will Win the Election? The problem states, 2 weeks before a presidential election, a polling organization asked a random sample of registered voters the following question. If the presidential election were held today, would you vote for candidate A or candidate B? And based on this poll, the 95% confidence interval for the population proportion who favor candidate A is this thing in parentheses, 0.48, 0.54. So first up, let us interpret this confidence interval. So we could say that we are 95% confidence that the interval from 0.48 to 0.54 or 48 to 54%, if you like percentages, captures the true proportion of registered voters who favor candidate A in this election. Second up, what is the point estimate that was used to create the interval? And what is the margin of error? So for the point estimate, I've labeled that PE. I add together the 0.48 and the 0.54 and divide that by 2, and that gives me a point estimate of 0.51 or 51%. And then our margin of error is, you can take the highest value here, so 0.54 or 54%, and you subtract the point estimate from it, so 0.51, and you get a margin of error of 0.03 or 3%. And then third, based on this poll, a political reporter claims that the majority of registered voters favor candidate A. Use the confident interval to evaluate this. So, what would we tell the reporter? Because there are plausible values of P, or a parameter for a population, less than or equal to 50% or 0.50 in the confidence interval, that interval does not give convincing evidence that a majority, which is more than 50%, at least in my mind, of registered voters favor candidate A. So while our confidence interval gives us an interval of plausible values for a parameter based on our sample data, there's something that goes along with that interval, and that is called the confidence level. So that gives the overall success rate of the method used to calculate the confidence interval. So that is that whatever your percentage is, so if it's 95% of all possible samples, the interval computed from the sample data will capture the true parameter value. So keep in mind that the confidence level doesn't tell us the probability that a particular confidence interval captures the population parameter. It just gives us the level of which we are confident in our use of our confidence interval. So we would say if we were to select many random samples from a population and construct a, for example, 95% confidence interval using each sample, about 95% of the intervals would capture that parameter in context. So confidence intervals and confidence levels go hand in hand. One way to get a better confidence interval is to decrease the margin of error. And so the margin of error gets smaller when two things happen. One, the confidence level decreases. So unfortunately, to obtain a smaller margin of error from some data, you have to be willing to accept less confidence. Kind of a bummer. The second way is that the sample size n increases. So we've heard this plenty of times before, but in general, increasing the sample size n reduces the margin of error for any fixed confidence level. And another little warning here is that the margin of error does not account for any sources of bias in the data collection process. So the margin of error is meant to account for only the variability that we expect from random sampling and not from things like undercoverage or non-response or any other types of bias that we know happens to exist. And the last new term I promised that we're going to cover in this video is something called a critical value. So that's a multiplier that makes the interval wide enough, so our confidence interval wide enough to have the stated capture rate. Another way to think about it is our critical value is the value of our statistic that we're testing, which defines our upper and lower bounds of our confidence interval. So one way to think about it is if we have our confidence interval and we have our statistic and we plus or minus our critical value, so if we wanted to do 2 intervals or 3, and then we multiply it by the standard deviation of our statistic. All right, and on our margin of error train, we're going to do one last example and call it a day. So we're going to be talking about what's your GPA, which I'm sure you love being asked. Our problem says, as part of a project about response bias, Ellery surveyed a random sample of 25 students from her school. One of the questions in the survey required students to state their GPA aloud. Based on the responses, Ellery said she was 90% confident that the interval from 3.14 to 3.52 captures the average GPA for all students of her school. So first, let's explain what would happen to the length of the interval if the confidence level were increased to 99%. So what happens is that the confidence interval would be wider because increasing the confidence level also increases the margin of error. So remember in the last slide, if you want to decrease margin of error, you got to decrease your confidence level. Be okay with less confidence. Second up, how would a 90% confidence interval based on a sample size of 200 compare to the original 90% interval? So what happens here is that we increase the sample size, which would mean our margin of error goes down. So the confidence interval would be narrower because increasing the sample size decreases the margin of error. And last, describe one potential source of bias in Ellery's study that is not accounted for by the margin of error. And I bet you could answer this before I show you my answer. So one potential source of response bias is the fact that the margin of error doesn't account for the fact that students might not be entirely truthful about their GPAs, especially when they're asked to respond out loud and there's no source of anonymity for them to hide behind. So I don't think you're getting the most truthful data. So the mean or the average GPA for all students might even fall beneath this 3.14 number if more and more students were inflating their GPA because they have to say it out loud. All right, as promised, that's going to do it for this video. Thanks so much for watching.